In this video, we will talk about compound factors. And compound factors are basically, if we have this equation, we take all of our equations and we convert it to these factors to simplify our calculations. So we reduce our dependency on computers by using interest tables. Because in school we can't use computers to solve our economics questions and their problems, we have to find a way to use our calculators. So what we do is, rather than using calculators to do these long equations, for example, if you were to find out the future worth of $1,000, if you were to find out the future worth of $1,000 for 3 periods at 10% interest, what you would get is 1,000 1 plus I to the power of 3. Now, back when calculators didn't exist, they would have to expand this out and solve for I. And solve for F. I is 10%. Now, that's only the third period. What if n equal to 20 periods, right? Or 100 periods? That's when things get complicated. So they created, before even calculators were made, they created this table. These tables take this factor over here and converts it into decimal places, into a factor, into a compound factor. Okay, so in this case, 1 plus I to the power of 3, or 1 plus 10%, 1 plus 0.1, so this would be 1 plus 0.1 to the power of 3. In this case, this would be converted into a compounding factor, which is basically at 10% at the third period. We're trying to find the future worth, 1.331. So this would get converted into 1.331, and we would multiply this factor by this $1,000, and we would get 1,331.00. So again, how do we use this table? We are just focusing on single payment, so future worth and present worth. Compound amount factor, meaning the compound factor, find F given P. So the way these questions are structured to figure them out from the compound interest factors is to basically set up the question. So we are trying to figure out how to find the future worth. So F is equal to, so the future worth is equal to the present worth times a certain factor. And this factor we find from our table, right? So we have to use some sort of method to refer our calculations to that table. So what we do is we do F given P, comma I, comma N. So we have to define what is it that we are trying to find. So we are trying to find the future worth given the present worth. And we are also giving you the interest rate and also for how many periods. So in this case, it's $1,000. We are trying to find F given P at 10% for 3 periods. So in this case, it would be times the factor, which we found to be 1.331. And that's our future worth. So that's what compound factors are for future worth. For present worth, it's P is equal to F times 1 plus I to the power of negative n, right? Or F over 1 plus I to the power of n. It's the same thing. Negative n means how many years or how many periods earlier do we want to find our present worth. So for example, if we are given the future worth 5 years ahead and we want to find out how much that future worth is worth 5 years earlier, we would put negative 5. So it's another way to think about periods. So P would be written as, to find P we have F, and we need to multiply this F by P given F. We're trying to find P given F, 10% interest for 3 years. And we take our F, which is 1331, and we multiply it by a certain factor. Now the factor is P given F. So we are trying to find P given F, not find F given P. So this can get confusing, so make sure you use the right column. So find P given F at 10%, and at 3 periods. So n is equal to 3, so 0.7513. We multiply this. We get 999.98. We are 2 pennies short because these factors are not exact factors. They were rounded off to the 4th decimal place. So yeah, that's how we get compounding factor of present and future worth of basically the single cash flow.